Okay, today we are continuing with displacement reaction, and here I have written the definition of displacement reaction. Let's see. When an element or a radical displaces another element or radical from a compound, then the reaction is called displacement reaction. How can we understand this easily? I want to show you with the symbol. Let's say this is an element represented by A, and this is a compound represented by BC. Compound has got two or more than two elements, that's why I have written two here. And if this reaction occurs in such a way that A displaces B and forms AC, another compound, and displaced B is here, then this is displacement reaction. An element displaced another element from this compound, and this is the result. Or a displacement reaction may be like this also. Let's say we have a compound AB, another compound CD. Now let's talk about this AB. AB both may be element or radicals. In CD also both may be elements or radical. Both may be element or radical in both the cases. And if the reaction occurs in this way, if the metallic part, this is the first part, metallic part of first compound, if displaces the metallic part of second compound, and the metallic part of second compound takes the place of metallic part of first compound, then our result will be like this. This A if displaces C and A is again displaced by C, then CB plus AD. This is also displacement reaction. This is the example only. Element or radical, when displaces another element or radical from a compound, then the reaction is called displacement reaction. Now it is of two types. I have written here. This first type is single displacement reaction, and second type I'll write later, double displacement reaction. It is written at the back. Okay, what is single displacement reaction? A chemical reaction in which an element displaces another element from a compound is called single displacement reaction. Means, just take example. Just for example, zinc is an element. When it reacts with sulfuric acid, when it reacts with hydrochloric acid, let's say, why to take sulfuric acid? It's better to take hydrochloric acid because there is something we have to balance. Then what is happening here? This is an element and it is reacting with a compound. And when a metal reacts with acid, then normally metal displaces the hydrogen of acid. And what happens now? Result, zinc chloride forms. Here valency of zinc is 2, chlorine is 1. That's why we have to transfer zinc, valency of zinc to the chlorine. So 1 is useless to transfer here because zinc itself is 1. But hydrogen, which is displaced from this compound, when becomes free, this is diatomic element. That's why we have to write S2. What happened? Zinc, when reacts with hydrochloric acid, zinc chloride forms along with hydrogen gas. This is single displacement reaction. An element is displacing another element from a compound. And if you want to balance this, hydrogen 2, if we take here 2, then hydrogen is balanced. Now chlorine 2, chlorine also here it is 2, zinc 1. It's okay. We can take another example also. Just for example, chlorine, which is when free, then it remains its diatomic state like Cl2. When chlorine reacts with potassium iodide, means Ki, potassium valency 1, iodine valency 1, equal valency, no exchange. When this reaction takes place, then this is single displacement. How? Look at this element chlorine, this non-metal. Non-metal displaces non-metal, not the potassium but iodine. Because chlorine is reactive than iodine, that's why it displaces iodine from this compound. And what happens? Now potassium chloride forms. Now we have to exchange the valency. Potassium 1, chlorine 1, equal valency, so no exchange. Now displaced iodine is free and iodine is diatomic, that's why we have to write I2. Yes. Now how to balance this equation? Iodine is 2, here it is 1. If we take here 2, iodine is balanced. Now it's turn of chlorine. Chlorine here it is 1, here it is 2. That's why we have to take here 2. Chlorine is balanced on both the sides. And potassium 2, potassium 2. This reaction is balanced single displacement reaction. Another example. Now I want to take another example also. Let's take another example. When copper reacts with nitric acid, what happens? Look at this. This is copper. I'm writing only symbol. You can write in word very easily. When it reacts with nitric acid, HNO3. This is nitric acid. This we remember from the previous class. We have to remember some of the acids and their formula. Copper when reacts with this, then metal when reacts with acid, then it displaces hydrogen from the acid. So copper displaces hydrogen and what forms? Copper nitrate forms, CuNO3. Now we have to exchange the valency. Copper valency 2, nitrate valency 1. 1 we don't have to exchange. Copper, 2 of copper should be transferred to nitrate, but we are transferring valency to a radical, so we have to put the radical in bracket, CuNO3 whole 2. Now displaced hydrogen when becomes free, it becomes diatomic. I mean to say it always remains in the form of diatomic state. It is in the form of molecule. Okay, now we have to balance it. Hydrogen 2, hydrogen 1. Here we have only 1, that's why if we take 2 here, then it is balanced on both the sides. Now it's turn of nitrate. Nitrate 2, here nitrate is 2, it's okay, balanced. Copper 1, copper 1. What formed? Copper when reacts with nitric acid, then copper nitrate forms and hydrogen gas. Here potassium chloride formed with iodine. Now let's talk about double displacement reaction. Displacement reaction is of two types. Single displacement, we took some example. Let's talk about double displacement reaction. We can define this way. Double displacement reaction, when the metallic part of first compound displaces the metallic part of second compound, and the metallic part of second compound takes the place of metallic part of first compound, then the reaction is called double displacement reaction. I told this here also, this way. Now we are talking about this double displacement reaction and we have to take example. Now let's take example. Let's say calcium chloride. Calcium valency 2, chlorine valency 1. That's why we have to transfer 2 here. Calcium chloride when reacts with silver nitrate. Silver is easy. Nitrate means what? NO3. This is radical. Valency 1, 1. Equal valency, no exchange. When they react with each other, then what happens? This is double displacement reaction. This is metallic part, this is non-metallic part, metallic part, non-metallic part. Metallic part of first compound displaces the metallic part of second compound. That's why here what happens? CaNO3. Now we have to exchange the valency. Calcium valency 2, nitrate valency 1. We don't have to give 1 to calcium, but calcium valency 2 should be transferred to nitrate. It is radical, that's why we have to put in bracket. Now next is this silver which is displaced by calcium Now it combines with chlorine. It means it takes the place of calcium. That's why plus another compound will be AgCl, silver chloride. Now both of them have valency 1. That's why no exchange. Now chlorine 1, chlorine 2. That's why I want to take here 2. Chlorine is balanced. Silver 2, silver 1. That's why I want to take here 2. It is also balanced now. Nitrate 2, nitrate 2. Okay, calcium 1, calcium 1. This is one of the example of double displacement reaction. Now let's take another also. Let's take sodium chloride, NaCl, sodium 1, chlorine 1, equal valency, no exchange. And if sodium chloride reacts with silver nitrate, Ag, silver, nitrate, NO3, when they react with each other, then what happens? Now sodium takes the place of silver and silver takes the place of sodium. Now what happens? Sodium when takes the place of silver, then NaNO3, sodium nitrate. Sodium valency 1, nitrate valency 1, equal valency, no exchange. And in the same way, now next is silver takes the place of sodium, and that's why AgCl, both of them have equal valency, that is 1. That's why no exchange. This week we can take some example, more example we can take, but this much is I think enough to understand single displacement, double displacement. Today I told you about displacement reaction and single displacement, and lastly what? Double displacement reaction. Okay, next class I'll talk about acid base reaction.